We have all used Flutter, we all love Flutter, but have you ever wondered what happens behind the scenes or whatever happens internally when you write your Flutter code? Well, if you are interested, I have got you covered. So let's get started. Before we dive into anything else, let's start by first knowing what exactly is Flutter. So basically, if you go by the textbook definition, Flutter is an open source, cross-platform software development toolkit created by Google. So the first thing we come across is open source. It means that all of the source code for Flutter is available to public. Next, cross-platform. It means that all the code that you write in Flutter will be combined for both Android and iOS. You do not have to maintain separate code bases for separate platforms. Finally, Software Development Toolkit (SDK) is nothing but a set of tools and services that Flutter provides to help you create apps easily. Okay, now that you know what Flutter is, let's look at the components of Flutter, or you can also call it architecture of Flutter. Alright, so on the left side, you can see an image, a diagram, which I've taken out from the official Flutter docs. I will put the link in the description so that you can learn more about it. And on the right side, I've written what each component refers to. So if you look at it, it's basically divided into 5 components: Dart app, framework, engine, embedder, and runner. So let's take a look at it one by one. So first of all, we have Dart app. So Dart app is the higher level app or the higher level code that you write in your IDE, right? So if I open up a example, here I have a simple responsive text component which contains layout builder and a few other widgets. So basically, this is my Dart app and this is owned by me. So we haven't gone into whatever happens behind the scenes, right? This is the high level code that we write. So this is what Dart type refers to, and you can see it says composes widgets into the desired UI. It makes a widget called responsive text by composing other widgets together. Okay, so second, it says implements business logic. So basically, whatever logic I write here, I may have some events, I may have some fetch requests, and whatever my app overall does, all that logic, it belongs to me, and that logic it consists in the Dart app component, and it says owned by app developer, as I just said. So this is basically the highest level of code that you write. All right. Then second, we have framework. Framework is something that we don't write in our code directly. It is provided to us by Flutter. So it says provides higher level API, widgets, gesture detection, accessibility, and text input. So if you look at this example I have over here, you can see inside my custom widget, I have used some things that are like not created by me. For example, this build method. I didn't create this build method. It is provided to us by Flutter and Flutter framework. So the Flutter framework exposes this build method, which we can use and which will do something while the app is being built, right? So whenever this widget has been built, Flutter will internally call this method and it will run our project. So all these things like this build method and the widgets that are provided to us like layout builder, text, and whatever, these are inside the Flutter framework, which we use. Also, it says composites the app widget tree into a scene. So basically, internally what Flutter does is whatever widget you make, so it composes multiple widgets together and creates an overall scene that you see on your display. Okay, so if you move on to the next component, it's called engine. So after the framework, we have gone deep down into the components, and you can't directly see what the engine does, as you can see the things that consist in the framework part, right? Because in the app you can see the widgets that you use like layout builder and text whatever, which come from the framework, but you can see that in your Dart app here. But whatever the engine does, it is not directly visible. So engine is the main part of the Flutter framework, and if you see what it does, it says provides a low level implementation of Flutter's core APIs, for example graphics, layout, and Dart runtime. So it is responsible for running everything. For example, here it says graphics, right? So whatever widget that you use from the framework, the engine is responsible for rendering it on the screen. Like for example, if I add an image widget, image asset or whatever, then it's the job of the engine that it renders it on your screen. And not only rendering, it also takes care of the layout. So for example, you have a text, a image, and multiple widgets. So wherever you position them, for example, top or width, top, or what is the height, what's the width, and what's the position of that widget, everything has been taken care of by the engine, and it's called layout. Basically, graphics, layout, and Dart runtime. What's Dart runtime? Dart runtime is the like overall management of the engine, right? Like for example, managing memory, managing inputs, and managing RAM and whatever data that's flowing in the app. That's the part of Dart runtime. So all that things, everything that contains the core functionality like graphics, layout, Dart runtime, it all consists inside the engine. Next, in the image you can see Dart UI written over here and Embedder API written over here. So basically, all these components in Flutter, they cannot access each other like freely, like like they are all enclosed in their own space. So the only thing that they can do is access their respective components that are above or below them, right? So to do that, you can see that in the image we have written Dart UI and Embedder API. It means these two are the APIs that the engine can access. So as for the Dart UI, the engine exposes this Dart UI API to the framework. So the framework can access this stuff from the engine via the Dart UI API, and similarly, engine can access stuff from the embedder using the Embedder API, right? So once we know all these components, it will be a lot clearer to you guys. Okay, so let's move on to the next component. It's called embedder. So embedder is something that is like different for different platforms. The first three things, these are similar in every platform, and the embedder is different. So embedder is different for Android, for iOS, and like whatever platform there is, right? So if you see what's written here is coordinates with the underlying operating system for access to services like rendering surfaces, accessibility, and input. So basically, embedder's job is to communicate with the operating system to provide the native features, right? What are the native features? uh, like the most basic native feature on mobile you can call is touch. So whenever we touch our screen, that's a native event that happens, and to read that event or to read the data from that event, it's the job of the embedder to provide that information to the engine. So whatever's happening on the very low level, the native stuff, it's the job of the embedder. So for example, you can see here rendering surfaces. Rendering surfaces is the area where our UI is rendered, and it's the job of embedder to like maintain that area and like give the layout of that area to the engine. Accessibility and input, it's quite clear. So basically, whenever you type via keyboard or via the on-screen keyboard on mobile, whenever that input comes in, the embedder's job is to provide that input to the engine so that we can update the UI. Also exposes platform specific API to integrate the embedder into apps. So basically, platform specific API is the same thing that whatever feature your platform contains, it's the embedder's jobs to communicate with that. For example, native features I already mentioned, and if you go to more complex features like Bluetooth and Wi-Fi, that's the job of the embedder to communicate with it. All right, so the last thing is runner. So basically, the first four components that we just saw are kind of related to each other, or they communicate with each other. But runner is is a different thing, you can say. So runner is also platform specific. You can see it's written over here. It's different for all platforms, and its job is to compose the pieces exposed by the platform specific API of the embedder into an app package runnable on the target platform, right? So we have got all the inputs from the embedder, whatever native thing we have created our app via the framework and the engine, and now it's the runner's job to package all that together into a runnable, and it makes sure that it is optimized for that particular platform, and it is runnable on the target platform. All right. So, and the last thing, it is generated by Flutter Create. Flutter Create is the command that you write to create a Flutter app, and it is also owned by the app developer. Okay, so now that we have gone through all the components and all the architecture, you might say, you can probably see the flow, like how things are working behind the scenes, right? For example, like I said, for the input field, let's take that only. So that if you write the input field in our app, it consists in the Dart app, and that input field is exposed to Dart app from the framework. The framework has already written the code for it, and we only use it in our Dart app. Now, the engine's job is to uh, like render that on the screen and take care of the layout and the styles, whatever you gave it to it, and render it on the screen. And it's the embedder's job to take the input from our keyboard or our on-screen keyboard and provide that to the engine, which provides it to the framework and which updates the data on the screen. And whenever everything is complete, it's the runner's job to package all that together into runnable that on the target platform, right? Okay, before we move on to our next topic, it is important to know what is a widget. So you might already know this, but still I will tell you for someone who doesn't know. So basically, everything you see in Flutter is a widget. By everything I mean, if you take a look at this code example, here you can see this our custom widget that we created, responsive text. This is a widget, and the things that we use like layout builder, this is also a widget, and like the constraints, the max width, whatever you see here, everything is a widget. The style is a widget which takes in a widget of type text style. It contains font size, which is also a widget. So basically, everything you see is a widget in Flutter, and we will see how those widgets work behind the scenes next. Okay, so we finally are here, and we will see now how the widgets are maintained and how Flutter uh, internally keeps track of all the widgets and the states of the particular widgets. All right, so here you can see on the left side we have an example, and this is basically a very simple widget which is just a container with some styles, and inside it contains an image and a text encapsulated by a row, right? And on the bottom we have some trees that I will explain in a moment. Right now just focus on the left tree. This one is called the widget tree. All right, so what is a widget tree, we will see now. So basically you can't directly see it when you make an app, but Flutter internally creates this tree to make it easier for Flutter to like maintain all the widgets and update its state, right? So basically, if I have to make up this widget tree from this code, how can I do that, right? So the first thing you see on the tree is a container, which is our topmost widget, and below that is a colored box. So what is colored box? So to a container we are passing a property called color, right? This color, if you hover over it in VS Code or whatever ID you are using, you can see the type of this property is colored box. So we are passing colors.blue over here. So the in the tree, the next child is called color box. Now we have a row, as you can see here, pretty straightforward, and this row has two childrens, right now we had a linear tree, now we have two childrens, image and a text. So here we have two childrens of the row, image and text, and you might think that it's over now, but we still have two more things over here. So basically this image.network is a higher level widget which internally contains another widget called raw image, and similarly the text contains another widget called rich text. So in the widget tree it is very clearly highlighted the higher level widgets and the internal widgets that you can't see and you can see. So the blue ones are the container row, image and text, which clearly you can see over here in your code, but the internal widgets are also shown over here. So this is a widget tree which Flutter creates every time when a build method runs. So what is a build method? You already know. Whenever we create a widget, it contains a build method which contains all the UI inside that widget, right? So whenever we run an app, this build method is internally called, and a widget tree is created for that particular component that you just wrote. Okay, so now what's the use of this widget tree? So for example, initially you have this let's look at this example. Initially you have this container that contains the image and a text beside it in a row. So Flutter creates this widget tree, and now imagine you update something in this widget, and for example, now the color of this widget is red, not blue, of this container, right? So to update that, like to make it more optimized, Flutter will go through this widget and it will know that the only thing that has changed here is the color of the container. So all Flutter has to do is come down the widget tree and update this colored box. It will change the color from blue to red and everything will remain same. So that's how the state update works, and Flutter only updates the state that is necessary. And internally, how it does that, we will see that next. So beside this tree you can see there are two more trees. One is a element tree and one is a render tree. So if you look at the right side of the screen, we have some notes about this tree. So the first thing I already mentioned, Flutter creates this trees at the build phase, right? Whenever the build method is called, all these things are created. And element tree is used for defining structure of the app and helps in maintaining state. So there is another tree that is derived from this widget tree. It's called the element tree, and it contains two components. Yeah, I have written three over here, just two components. One is component element and second is render object element. Now I understand that this is too much, you don't know what this means. These are the lowest level classes of the component, any component that we use, and it basically means that the component element is what you write, like it does not render on the screen. It's just a component which has some layout and it has some what can you say, a structure, but it does not render on the screen directly. But render object element is something that renders on the screen, right? So if you look at this widget tree, a container is an high level widget which contains things like colored box inside it, but what you see on the screen is only the colored box, right? If I create a container and give it a height and width and like set the color to blue, you can only see the color blue. You cannot see the encapsulating container, that the container class, you can't see that on the screen, right? So it's called a component element, while the colored box is called a render object element. Now you might say that row should also be a component element, but no, because the thing that's inside the row decides how it is rendered, right? So if you put it in a row, it will be rendered in a horizontal manner, so that's why it's also a render object element. So that's how it creates an element tree, and this helps in defining the structure of the app. So whenever we are rendering objects on the screen, this is how Flutter knows what to render and what to not, and like component element will decide the structure of the app while the render object element will be rendered on the screen. All right, so the next tree is called the render tree, and render tree is used for rendering UI on the screen. So this is also very similar to it, but there are some differences. So if you see here, it consists of render object, base class, and its derivatives. So now that Flutter knows from the elementary that okay, I have to render this thing, right? So in the other tree, only the render object elements will be present. You can see only 4 elements are present in this tree, and the component elements are not there, right? So now we know from the elementary that okay, I have to render this colored box. So to render the colored box, it will create a render tree and refer to that while rendering. So how to do that? With colored box, the base class of the color box, like the very base class, the foundation of color box for rendering is called render decorated box. Similarly, if you go below, the base class, the render base class for row is called render flex. For image, it's called render image, and for text, it's called render paragraph. So these are the lowest level classes that are written in the Flutter engine and Flutter framework that Flutter uses to render on the screen. So that's called the like the render tree. And one more thing, all these classes are derived from render object. So render object is something that is rendered on the screen, obviously, and these are the derivatives of it, which are customized for different widgets like the colored box, text, image, and whatever you have here. So that are the three different trees. I told you how it maintains state, how it renders element on the screen, and how it updates the state of the widget, right? So yeah, so these are the three different trees that Flutter uses internally. So this has been a brief overview of Flutter. So hopefully by now you guys know the overview and the architecture of Flutter. What are the different components that come together to complete your app, and you know how Flutter maintains this different kinds of trees internally, and how it uses it to update and maintain the state. Also, hopefully you know a little bit about how Flutter renders your UI on the screen. So this is it for this video, and I'll see you in the next. Cheers.